endurance performance. That is the improvement in cardiovascular endurance performance. The first of which is caffeine, methylxanthine family. It's a naturally occurring stimulant. It affects the central nervous system, the myocardium. It promotes diuresis, or frequent urination, and epinephrine release into the bloodstream. You can alter the amount of calcium handling in muscle. It affects the sodium-potassium pump. It affects cyclic AMP, which is a second messenger in cells. Glycogen phosphorylase is also increased, which helps break down glycogen to release glucose molecules for use in glycolysis. Sources of this: tea, coffee, chocolate, soda, of course, tablets. The claim here is that we can increase lipolysis from both stored muscle triglycerides and adipose tissue, which means if we can increase the amount of free fatty acids floating around in the bloodstream, as well as intramuscular triglycerides, that will increase fat oxidation and then spare muscle glycogen. And in cardiovascular endurance, it's all about sparing muscle glycogen so that we can have more fuel to keep us going at whatever pace we're trying to keep up with for the amount of time that we wish to perform at that level. Usually this works for moderate intensity, not so much for high intensity work. It also is going to increase performance and alertness. The efficacy and evidence for this, it actually may spare glycogen in the first 15 to 20 minutes of submaximal exercise, again at moderate intensity. There are a lot of studies that were done using cyclists, so it seems like it has more effect in cycling versus running, but that may just be due to the fact that there are more studies done on cyclists rather than runners. Usually more than an hour in duration of exercise duration. It's again not useful for high intensity work, especially work that's very, very short in nature. Side effects of this: well, it is banned by the International Olympic Committee, so it'll give you a positive urinary test, which would mean that you would fail your drug test. You're prone to tremors, tachycardia, so accelerated heart rate, headaches, dehydration. There are some people who don't respond to this. There is some habituation to it, so the more that you drink a beverage that has caffeine in it, the more that you consume caffeine, the less likely you are to get any ergogenic aid from it. You can make yourself caffeine deficient by not consuming it for about 3 to 5 days, and you'll then again, since you've deprived yourself of the caffeine, respond if you had responded previously to caffeine as far as exercise performance is concerned. The application of this, the traditional dose is about 6 to 9 milligrams per kilogram of body mass about an hour before the event. The newer recommendations suggest 1 to 3 milligrams per kilogram of body mass per dose, and it also may be best if you consume it with carbohydrates just about an hour before the event. You could also do 6 1 milligram per kilogram doses over 2 hours. There's some evidence to suggest that maybe that's the way to go. Coffee might not be the best source because there are other chemicals in coffee that may actually degrade performance, so that may not be the way to go. It has it is very difficult to produce any sort of real-world applications simply because of the habituation and the timing of ingestion and the way that you would ingest it in tablet form or the beverage that you use to consume it. So it's kind of a tough one to play around with. So really the important part here is if you have an athlete that wants to use caffeine as an ergogenic aid, then they need to practice the consumption of caffeine far in advance of the athletic event. Okay, so this is just a slide showing you the amount of caffeine in milligrams in a variety of food products. Branched-chain amino acids, or BCAAs for short. These are essential amino acids. There are 3 of them: leucine, isoleucine, and valine. Where do we get these from? Foods containing protein. The claim here is that we're going to enhance endurance performance and also enhance post-exercise recovery. The efficacy and evidence, there are mixed findings with branched-chain amino acid supplements. We find some increase in mental performance, some improvement in cycle endurance performance, reduced marathon completion time. It's been compared with carbohydrate in some studies, and actually carbohydrate consumption was equal to the effect of branched-chain amino acids. So we're not quite sure what's going on there with the branched-chain amino acids. So caution is warranted here. Side effects of this: 3 to 25 grams per day. No adverse effects are going to be reported. Higher doses may increase the risk for competitive inhibition of other essential amino acids. So the idea here is that amino acids have transport systems, very specific transport systems in the gastrointestinal tract. And if you have an overabundance of one particular type of amino acid, that amino acid, because the concentration gradient is so high, may actually inhibit the absorption of other amino acids simply because there's more of the branched-chain amino acid, for example, around. So you really want to strike a balance of all the amino acids so that we don't run into a situation where you have competitive inhibition and then perhaps the person becomes deficient in a couple of amino acids. The direct application of this is going to be 3 to 20 grams per day, taken before or during exercise or post-exercise as a recovery aid. Carnitine in the L or D form is a protein. It is found 98% in skeletal and cardiac muscle, so it's an important part of muscle. And the main function of carnitine is to essentially transport long-chain fatty acids, or LCFAs, into the mitochondria so you can utilize them to make ATP for oxidation purposes. So carnitine is very, very important in that regard, and so sources of this endogenously produced, lysine and methionine, two amino acids put together, you make carnitine. You can get it from meat, poultry, fish, dairy products, peanuts. The claim here is that since we can increase transport of fat into muscle, well, then we must be able to increase the amount of fat oxidation and enhance fat loss and even increase endurance cardiovascular performance. The efficacy and evidence for this, it seems to be pretty weak, especially in healthy people, saying that carnitine loss is really negligible, day to day. Side effects of this: L-carnitine is generally safe. You want to make sure that you're getting the L isomer and not the D isomer, simply because the D isomer can actually deplete L-carnitine, and then you will in fact run into a deficiency state. The application of this, about 2 to 6 grams per day. It might benefit patients who have a carnitine deficiency. There's some evidence even to suggest that patients with peripheral arterial disease, or basically cardiovascular disease in the limbs, lower limbs, that it may improve blood supply and oxidation and help with intermittent claudication or calf pain in those patients. It might benefit some vegetarians whose diet may be low in lysine and methionine. Those are the two limiting amino acids primarily in a vegetarian's diet. So by having some carnitine, perhaps you'll improve carnitine status and then enhance fat oxidation. Okay, coenzyme Q10 or ubiquinone, it's found mainly in the mitochondria, skeletal muscle, and the myocardial tissue as part of the electron transport chain, or ETC for short. It's necessary for electron transfer so that you can make ATP. It also has antioxidant properties. Sources of this: animal products and a few plants. The claim is that you can increase the amount of vigor that someone has and increase energy production because it is part of the electron transport chain, and decrease the oxidative damage of exercise. Efficacy and evidence for this, as far as increased performance goes, so improvements in cardiovascular type of work, there doesn't seem to be any supportive evidence for that. In fact, it may actually be ergolytic, which means that it will reduce exercise performance. There are a good number of research studies that have analyzed coenzyme Q10 as an antioxidant. So in that regard, it seems that coenzyme Q10 does have some merit. As far as side effects are concerned, increased oxidative damage from high-intensity exercise may result in combination with consumption of coenzyme Q10, and some gastric distress, heartburn, nausea, stomach ache. Direct application of this, 50 to 100 milligrams per day. Patients with myocardial ischemia might actually improve their exercise capacity, and patients on lipid-lowering medications may also benefit from coenzyme Q10. Dimethylglycine, or DMG, It is also known as vitamin B15, but key point here is that it's not a vitamin and it's not essential. It's also known as pangamic acid. Sources of it from food include brown rice, brewer's yeast, grain, sunflower, and pumpkin seeds. The claim here is that we can improve what's called VO2 max, or the maximum amount of oxygen that someone can consume. That simply just means that they're cardiovascularly, cardiorespiratorily capable of handling exercise. So in other words, the higher your VO2 max, the better your cardiovascular performance is going to be. So if you can increase VO2 max, then they might translate into improved cardiovascular performance. You can also get decreased lactate formation because of a higher VO2 max. If you can work at a higher percentage of your VO2 max, or increase the VO2 max and work at that same level that you've been working at, you will reduce the amount of lactate in the blood, which blood lactate formation is associated with fatigue and reduction in performance. So if you can keep those levels lower, then you can enhance performance. The efficacy and evidence for this, currently there's no supporting evidence for these claims. The side effects. The natural form is regarded as GRAS, that stands for generally regarded as safe. The synthetic form is illegal and it's quite harmful, so be careful there. The application of this, 300 to 600 milligrams per day to control seizure frequency in epileptics. Ginseng. Ginseng comes in a variety of different forms, which actually is one of the problems with ginseng, as we'll see with the practical application here. It's considered an adaptogen. This is a substance that helps the body adapt to stress. It's going to contain things like saponins, which are active ingredients that also function as antioxidants. The source of this, it basically is extracted from the roots of plants. The bioavailability of the active substances within the ginseng is really going to depend upon how you extracted it, the plant variety, and of course the final form that it's in. So that's something that you want to be aware of, that since there are so many varieties, when you're evaluating the literature, we want to try and compare studies that were done with similar substances, and perhaps even a comparison of the effects of all the different varieties here. The claim here is that we can reduce the amount of fatigue, increase aerobic conditioning, increase strength, increase mental alertness, and improve exercise recovery. Efficacy and evidence as an ergogenic aid for cardiovascular endurance. It seems insufficient right now to use this as a ergogenic aid. Side effects of this, it's considered GRAS, generally regarded as safe. However, in hypertensive and hypoglycemic individuals, caution is warranted because it might exacerbate those conditions for those patients. Application of this, about 100 to 300 milligrams per day for 3 to 6 weeks, and then you would cycle that schedule. So you would be 2 months on and then 1 month off. As a dried root, 1 to 2 grams per day for the American ginseng or Panax ginseng, and 2 to 3 grams per day for Siberian ginseng. Again, since there are so many varieties and different ways of extracting the plant root and getting the ginseng, there's a lot of variability, and you want to make sure that you're reading labels and knowing what you're getting in the product, and of course analyzing the scientific literature for which type of extract was used as an ergogenic aid. Pyruvate and dihydroxyacetone. Pyruvate is basically a salt form of pyruvic acid, and pyruvate is the end product of glycolysis. So here over to the right, you see glycolysis in its full form with enzymes included, and I've drawn circles around pyruvate. So it's the end product of glycolysis, and if pyruvate is allowed to go on to the next step, which would be the TCA cycle, then it would be converted in acetyl-CoA. However, under conditions where oxygen delivery to muscle tissue is insufficient, so in other words, high-intensity exercise is being performed, then pyruvate will be transformed into lactate. The source of this, soybeans. Most athletes are ingesting the soybean form, but you can also get it from animals consuming the cerebral cortex of animals. The claim here is that we improve endurance capacity, we can improve insulin sensitivity, enhance recovery from cardiovascular exercise, increase glycogen storage, and promote fat loss. Efficacy and evidence, currently there's weak supporting evidence for the use of pyruvate in this regard. Side effects, borborygmus or bowel rumbling, flatulence, diarrhea. Application is about 1 to 5 grams per day. Clinical studies are using 25 grams of pyruvate and 75 grams of dihydroxyacetone. And of course, the downside of this is that it's very, very expensive. Lactate salts and polylactate. Lactate is good fuel for the human heart. The heart loves lactate and consumes it in copious amounts. You need high amounts of sodium or potassium salts to absorb lactate, so that's important. So that brings up the issue of osmolarity problems. Are you going to upset the GI tract osmolarity? The polylactate polymer has been known to reduce osmolarity, and it's not well digested. So in blood, where are you going to get this from? Basically, muscle tissue. As we outlined in the previous slide with glycolysis, when pyruvate is accumulating because it's not going on to the next step, the TCA cycle, because of high intensity work being performed and insufficient delivery of oxygen to utilize the oxidative processes to a large extent, we will convert pyruvate into lactate. And the reason why we're doing that, there are several reasons, but the main one is really to keep glycolysis going. Otherwise, if you didn't do that conversion, pyruvate would basically shut down glycolysis. So if you want to maintain whatever level of activity you're doing, you have to do something with the pyruvate. And what we do is convert it to lactate. So the idea here is that if we have more lactate around, that perhaps we increase the fuel availability, which means that we can increase performance and reduce the time to exhaustion. Efficacy and evidence for this, there's really no supporting evidence for the use of lactate. Side effects, gastrointestinal distress, application 10 grams per dose before exercise. Phosphorus. This is an essential nutrient. It's a mineral. We have about 850 grams in the human body, most of which is located in bone. It's part of the phosphagen system, so part of ATP, part of creatine phosphate. It's used as a buffer. It's used as part of the B vitamins. It's used in making 2,3-diphosphoglycerate or 2,3-DPG, which is used to make red blood cells. It's also a structural component of cellular membranes and nucleic acids. It's abundant in a variety of foods, so it's easy to get. And the claim here is that we can, quote-unquote, phosphate load, and we'll get improved performance because we'll enhance ATP synthesis, we'll improve oxygen extraction in muscle because there are more red blood cells because of the increase in 2,3-DPG as a creator of erythrocytes. Efficacy and evidence, insufficient evidence to support these claims or inconsistent findings, so we definitely need more research in this area. Some of the side effects include upsetting calcium balance and perhaps even some bone loss. There's the possibility of interrupting iron absorption and then upsetting the iron balance and iron status. So these are concerns that we have with too much phosphorus in the diet. Application of this about 4 grams per day. Bicarbonate. This particular equation that I have listed here under the description, this is called the Henderson-Hasselbalch equation. You may have seen this in your physiology courses. Bicarbonate exists right here in this part of the equation. And if you look at the right-hand side, we have hydrogen ions that can be released from high-intensity work. So lactic acid, lactate, is where we're going to generate a lot of these hydrogen ions. These are acidic components that will be combined with bicarbonate. And bicarbonate is acting as a buffer so that eventually we can breathe off that acid and mitigate pH balance by breathing off CO2. So we essentially get rid of some of the lactic acid by breathing it off as CO2. And bicarbonate is a very, very important player in making sure that that happens. So bicarbonate is essentially baking soda, sodium bicarbonate. So the stuff that we have in our refrigerators to eat up odors, we could actually ingest that to create a more buffering capacity in the blood. Sodium citrate is also another source of bicarbonate. The claim here is that if we increase the amount of blood bicarbonate, that we increase the buffering capacity, we decrease the onset of muscular fatigue because we can contend with all of the lactic acid that's being released from working muscle and into the bloodstream. And so it seems to work for high-intensity exercise conditions, or I should say this is the claim, anywhere from 1 to 7 minutes. The efficacy and evidence, there is some moderate improvement in higher intensity exercise. And generally speaking, the higher the metabolic acidosis, the greater the ergogenic effect will be. Side effects of this, it's relatively safe. However, you can upset the GI tract and result in cramping or diarrhea if you're not dosing it properly. So, practical application of this, about 0.3 grams per kilogram of body mass 1 to 2 hours before exercise in the form of sodium bicarbonate or sodium citrate. You do need to take some water in as well with it because otherwise you'll get a hyperosmotic diarrhea. So basically what happens there is you increase the concentration of bicarbonate that draws water from the enterocytes in the opposite direction. So instead of being in the bloodstream, now it's going out into the gastrointestinal tract, and that results in diarrhea. Medium chain triglycerides. These are fats, or a type of lipid. They contain 6, 8, 10, or 12 carbon atoms. They're easily reabsorbed in the gastrointestinal tract. They don't require any fancy transport systems like lipoproteins to carry them into the enterocytes and thus in the bloodstream. Sources of this, extractions from coconut oil, palm kernel oil. Claim here is that we can spare glycogen and delay muscular fatigue. We can also increase metabolic rate for weight loss. And we can produce ketones, which might spare muscle mass. The efficacy and evidence of this, it seems mixed and doesn't seem like there's anything there as far as an ergogenic aid in improving cardiovascular endurance. The side effects of this, ketone body production. When you increase the amount of ketone bodies in the blood, that can upset the pH balance, make it more acidic. And so in diabetics that are particularly not well controlled diabetic patients, then we want to be careful in this population. Also patients with liver disease, because ketones do get processed through the liver as well. We want to be careful there. And you might get intestinal cramping with large doses of medium-chain triglycerides. The application of this, about 1 to 2 tablespoons per day, or 14 to 28 grams of total fat. Glycerol or glycerin, which is a 3-carbon alcohol. The backbone of this is part of triglycerides. So glycerol forms the backbone of triglycerides, where then you would attach the fatty acids to. It's released during lipolysis. It's evenly distributed throughout fluid compartments, and it has some effect on osmotic pressure, so the distribution of water in the human body. Sources of this, dietary triglycerides. Claim here is that glycerol forces hyperhydration in the extracellular spaces. So these are the spaces outside of the cell. So outside of the cell, we're going to force more water in these areas, so mostly the plasma, so in blood. So if we can increase the amount of plasma volume, then in a hot and humid environment, we might actually be able to maintain better hydration and maintain good performance. The efficacy and evidence of this is insufficient and non-conclusive at this time. It is a banned substance, so if you get caught using it and you're competing at a high national or international level, you will be disqualified from competition. The other side effects here, nausea, gastrointestinal distress, diarrhea, headaches from increased intracranial pressure, so you're actually building up more fluid in the skull. Heartaches, blurred vision, dizziness, lightheadedness. Patients who are pregnant, hypertensive, or who are a diabetic patient or have renal disease, it's not recommended for those individuals as well, because they have issues with fluid distribution. The application of this, basically, if you're exercising in extreme hot and humid environments, then you may want to consider this. It's reserved for well-trained athletes. about 1 to 1.5 grams per kilogram of body mass of glycerol, with about 25 to 35 milliliters per kilogram of body mass for fluid. It needs to be consumed slowly, about 1 to 2 hours before competition, and to get the water retention and expansion of about 600 milliliters. It's recommended that you only use this under supervision of a sports scientist and or physician. Okay, carbohydrates. Carbohydrates is a macronutrient. It includes fiber, polysaccharides, oligosaccharides, disaccharides, and monosaccharides. It's abundant in both plant and animal sources. So when animals eat plants and we eat the animals, we are consuming some carbohydrates there. Of course, plants get it from photosynthesis and the sun. The claim here is that we can increase endurance performance, decrease the time fatigue, and even attenuate exercise-induced alterations in the immune system. Efficacy and evidence, there are a whole slew of studies that have looked at carbohydrates as an ergogenic aid. It really is the go-to ergogenic aid when you're dealing with a cardiovascular endurance athlete. It's usually the first thing that's tried. There's also evidence to suggest that we have reduced leukocytes, IL-6, IL-1, natural killer cell activity, granulocyte, and monocyte phagocytosis, which means an improvement in the immune response. There's also evidence to suggest that it lowers the neuroendocrine response, so you're going to have lower levels of cortisol, epinephrine, and growth hormone, and improve the amount of glucose available, and of course, insulin levels. Side effects here, none reported. There can be some gastrointestinal discomfort with polysaccharides. They're really big carbohydrates if you consume those within an hour of competition, simply because if you're trying to digest these polysaccharides that are huge and then you suddenly start to exercise, you're going to divert that blood flow away from the gastrointestinal tract to the working muscle, and that can cause some discomfort. So other populations that must be careful with this are diabetic patients, since they're going to have to accommodate all of this carbohydrate now and regulate their insulin accordingly. Application of this, about 7 to 10 grams per kilogram of body mass per day. Beta-hydroxy beta-methylbutyrate, or HMB. It's a metabolite of leucine. It's an amino acid. About 0.25 to 1 grams of HMB are produced every day endogenously, so within the body. Sources of this in food: catfish, citrus fruits, breast milk. Our claim here is that we can increase muscle mass, increase strength, improve recovery from exercise, decrease fat mass, use it as an anti-catabolic agent, decrease plasma cholesterol levels, and protect against stress. Efficacy and evidence, there's limited data for increased muscle mass and strength, and it's inconclusive at this time. There's some evidence that it may work as an anti-catabolic agent, particularly in cancer patients and AIDS patients. And it may actually work for individuals who are undergoing intense exercise training as well. There is some evidence that it may only work in novice trainees for short durations, about 2 to 4 weeks. So is there an adaptation to response to supplementation? So somebody who's an elite athlete may not actually get a response from HMB. Side effects here, none reported, up to about 6 grams per day. The application of it, 3 to 6 grams per day in 2 to 3 divided doses.